If you want to move around in that, so here I have my lovely example. We use mmap perfectly. We have this $shared variable which has room for 4-byte answer from the meaning of like function. The specific details of how mmap works I'm not going to get into too badly, but yeah, it's giving me 4 bytes of mmap memory. That's where I'm going to have to store my meaning of like answer. If I assign it that way, it isn't going to work. Perl will just toss that 4 bytes of memory and reallocate it because it's actually a scalar. It's nothing like it. There goes that work. The correct incantation to replace the 4 bytes of memory mapped memory in $shared with the meaning of life is that subster L value thing. So subster $shared, 0 is the offset, 4 is the number of bytes, equals, and then I'm packing along. The meaning of life is returning presumably a local. There you go. Now I have it. Got my answer. I actually have to deal with it.
Sorry, so what happens to the memory that was initially allocated to share in the public example? Is it
Now, older versions of this mmap would eventually crash because you would unmap the wrong thing.
Yeah.
The latest version I tested this on, it didn't crash.
Got it.
But the memory allocated. That's the outcome that you could expect.
Okay.
I mean, the memory is gone. The mmap backing is still there. If it's a public mmap backing. Actually, this is map shared, so it's definitely around still. Use bytes. Use bytes is a pragma, which occasionally saves you from horrible things happening. So we use Pack and Unpack with binary data a lot, except we're storing this binary data in Perl scalars, and Perl scalars are usually treated as strings by the language. Perl is kind of trying to be very clever a lot of the time, and one of the ways in which it's clever is in the ways that it sometimes recognizes Unicode, upgrades strings into Unicode, and things like that. And it has bitten us a couple times in very painful ways. Use bytes is this pragma that you put in scope somewhere when you're planning on dealing with this binary data. And its meaning is, no matter what you think might be in this view, do not cleverly switch to character semantics when I'm not looking at those. It's mostly useful for, it's actually, so I should be clear, yeah, Pack and Unpack don't care. They always treat scalar as bytes. They aren't the problem.
When you say in this ED, which one is this?
Oh, sorry, any.
Okay, any
that's in scope of the pragma.
PD is the string value.
Yeah, the PD is the string value that underlies the chart. The PD is the pointer value inside your scalar. Pack and Unpack don't care. It's when you're doing things like length and subster that you have to worry. I went for a browse. We had a bug at work, and I went for a browse through the code, and I'm trying to remember which function, the Perl source code itself. I'm pretty sure it was subster. That where you walk into this function and it's like if it's Unicode, do one thing, and if it's not, do something completely other. Two completely distinct code paths. And I gather that the sort of core string functions in Perl all have this sort of dual nature. Anyway, we don't, for what it's worth, we use Pack and Unpack a lot. We don't use bytes everywhere. We use it in small scopes around places where we have actually experienced problems.
You might be pointing out to use it?
What's that? We actually need character semantics, but we can't use it everywhere. We're going to get into really horrible stuff in a minute, so I would like to eat a donut.
Are there donuts?
The patterning that looks like code. Anyway, horrific abuses. What you all really came here for.
Where's our fruit to grow after you don't like them?
I did not. I provided the donuts.
No, you can throw some naan.
Like a C programmer. So this is just a little bit of C code to give you a feel for what I'm talking about. which is basically what I unfortunately couldn't dig up the exact quote. But I recently read an interview with the C++ group. I don't know how to pronounce it.
Well, is this a joke interview?
No, it wasn't. It was, he was very serious. And one of the things he pointed out was this, he had a very elegant term phrase, which I'm going to mangle horribly, but basically that in C and C++, there is a really direct correlation between the data structures that you declare and their representation in physical memory. So a C programmer looking at these things, basically I'm declaring a record. Does everyone read some C at least? Everyone reading all right. That when you declare this structure and then you declare you declare the shape of the structure, you declare an actual structure, you know where the elements of that structure are relative to the beginning of that structure automatically because of the way that it's. These are language guarantees, you see. So given this structure and these declarations, where is things.a? This has exactly the same address as things. There's no overhead of this structure. Where is things.b? It is 1 byte past things.a, which is 1 byte past the beginning of that thing. Then if you declare an array of 1,000 things, where is the B element of the second element of the array? It is at lots of things plus 2 times the size of 2 things plus 1. It's just, you just know, given your declaration. Sorry, I'm counting from the 2 elements. Where is my point? It's on the next slide. So, given a format, CC, which has the same byte representation as that previous struct, it's 2 chars. A C is a single byte. Given that format, remember that Pack manufactures unmaps. So I pack that format and I have it 2 bytes, $things. Where's things.a? It is at unpack. Well, so this notation may be funny. C, the X is there for hopefully a little bit of clarity. It just means skip a byte or ignore a byte or offset a byte, however you want to talk about it. Whereas things.b, it is at unpack xb. So skip 1 byte and unpack 1 character from there. That will return the second byte of that structure. If I declare, so this is actually new, I think, so you have dollar format wrapped in parens, 1,000 past it, you can multiply a template, a sub-template, if you will, from grouping CC as a sub-template, and I'm saying 1,000 of those. So now I have a 2,000 byte pack structure called lots of things. It is exactly the same in-memory representation as this 2 things.
Except for not. As he pointed out. Where the thing, your example here is actually 3 characters.
Is it?
Yeah, your early example is also 3 as well. Because you do element 2, 0, 1, 2.
Oh, I just said I said the second, and it was actually the third. And yeah, it's the same. It makes the same error with my language here. Yeah. Whereas the third element of lots of things, and the second character inside that, it is at unpack XX. That is, skip 2 bytes. 2, this is wrong. Should be 3. XC. So skip 1 more byte and pull out 1 character. So this is how you basically do pointer arithmetic.
Oh. Wait, is it wrong? Is it you want 0, 1, and then skip 1 and 3, and get B?
I
think it's right.
It might be. Yeah, I think you're right. Yes, you're right. Skip 2. Yes, that works.
Okay, you got it right.
Cool. Oh, yeah. Okay. I read the line above that as things 2.b.
So, what am I getting at? That in C, again, you have this direct correlation between the data structures that you declare and the bytes that underlie it. And so you do it's just natural to think about things like byte offset, jumping around in these things in a random access sort of way. Things that in Perl, the language just does for you most of the time, and when it doesn't, it sucks. And that's what I'm getting at. And then back to my older slide about how bytes are language neutral, and language neutral is really just